A person in an elevator moves upwards with an acceleration of 2 meters per second square. So there is an acceleration of 2 meters per second square, and he's in a lift and he's moving upwards. And the person tosses a coin with a velocity v equals 20 meters per second. After how much time will the coin fall back to his hand? So here this is an accelerated frame of reference wherein you have an acceleration of lift which is going upwards. So let us take this coin alone. So this coin is governed by two forces. One is the acceleration due to gravity and the other is the acceleration of the lift. So what is the net force on this particular coin? Net force on this particular coin is mass of the coin into net acceleration. Net acceleration, that is what we want to find. So what is that? F net is also equal to minus mg, which is in the negative direction. I have taken downward direction as negative, minus m into plus a because it is going in the positive direction. So I get minus of mc, this is mc into g plus a. So you would see that the net acceleration, so this equation and this equation, if you compare, net acceleration equals mc would get cancelled, and you would see that it is minus of g plus a, and the negative sign indicates that it is in the negative direction. So the negative sign indicates that this is in the negative direction. By doing so, what you have done here is ultimately you have made the problem look into a way such that the lift is stationary and only the coin is moving. So we will talk about that, or we will see how it has been done once we solve this problem. So now we have to solve this problem. So what is the total time that is taken by this body to come back to the person? So you know the net acceleration, you know the initial velocity, and you just need to know the total time that it takes for the ball or the coin to come back to the person. So if the person is standing here, it goes there and it comes back, how much time does it take is what we have done. So in this case, v equals u plus at. So v equals u plus at, and that is basically for this upward motion. So that is basically for this upward motion. So you should know that time t equals, at the upward point, velocity v equal to 0. So the time taken to reach the topmost point will be equal to u by a. So the total time that it takes for the coin to go up and then come back will be, this is like the total time upwards, and total time t will be equal to 2u divided by a. You would have already seen all those things in your one-dimensional motion problems. So in this case, the acceleration a net is given by 2u divided by g plus a. 2u divided by g plus a. So what is the velocity? It is 2 into 20 divided by, what is g plus a? G is 10 plus 2 equals 40 divided by 12, and you can write that as 8 into 5 divided by 4 into 3. So you get this as 2, that is, you get the acceleration, or you get the answer as 10 by 3, which is 3.33 seconds. So let us understand from a concept perspective what this all means and how does this actually lead to a better understanding of the problem, right? So what this means is that if the person is here is accelerating with this particular acceleration and moving upwards, he would have moved a certain distance d, and at this time when he was moving upwards, he tossed the coin, which means that when he moved up a distance d, the coin would have moved up, gone above, and then come back, and it would have covered only this much distance. It would have gone this high, and then while it came back, it covered only this distance, which means that the total displacement by the coin will be equal to the total displacement by the lift. The total displacement by the lift should be equal to the total displacement by the coin. So we already found out that the coin takes 10/3 seconds to go from here and to reach here, and by the same time this lift would have moved upwards. So let us see if we solve this problem independently without using the conversion of frame of reference. So the equation of motion for the lift alone will be S equals ut plus half at square. Let us assume that it starts from rest. So it travels a distance of d equals half into what is a, acceleration is 2, and time t we already found that it is 10/3, which is 10/3 whole square, and you get 2 and 2, which is getting cancelled, and which will be equal to 100 divided by 9. Now if we were to be correct, if we find the distance or the displacement of the coin C separately, we are supposed to get the value of 100 by 9. That is what it means by this concept. So what is the displacement component of the coin? Displacement component of the coin dc equals, again, ut minus half gt square. In this case, there is no conversion of acceleration. There is no relative acceleration with respect to each other, because we are considering this as two independent bodies. So what is that? So u is 20, and we already know that it is 10/3. We are just trying to check our understanding, that's about it, into 10 into 10/3 whole square. Okay, so this is 20 into 10/3 whole square, and this half into 10 into 10/3. This is no whole square here, so that's 200 divided by 3. So I take 100 divided by 3 outside of the equation, and you get 2 minus 10/5. 10/2 is, so I write this equation as 20 into 10/3 minus half into 10 into 10/3 whole square. So you get 100 as a common that you can take out, and then you write 2/3 minus 10 divided by 2 is 5, and then you get divided by 9. So this you can write as 100 into, you can multiply the numerator and denominator by 3, which means that 6/3, 6/9 minus 5/9. 6/9 minus 5/9 is 1/9, and you get the answer as 100/9. So that is nothing but the DC, the displacement that the coin had independently is equal to the displacement that the man had displaced while in the lift. And we found those two things independently, find that they are the same. And that is really the concept behind this problem. But to solve this problem, you don't need to go by this. You just need to convert the frame of reference as we did earlier. So the answer to this particular problem is 10/3, which is 3.33. We just understood the concept on how it is to be done.